From time to time, astronomers need optical assistance, and conveniently, unique effects occur in the vastness of space that open up a direct insight into remote, actually invisible structures. One of these effects, predicted by Albert Einstein almost 90 years ago, is the phenomenon known as gravitational lensing. Structures detected with the help of this cosmic magnifying glass remind us that equally gigantic and enigmatic colossi lie dormant out there in the universe. On the one hand, black holes like TON 618 and Phoenix A, with their tens of billions or even trillions of solar masses, defy all known laws. On the other hand, their very existence in this form shouldn't be possible according to current theories. Even Albert Einstein was not infallible. Quite the opposite, in fact, the creator of the theory of relativity was once so convinced of a rigid and unchanging universe that he added a cosmological constant to his equations. This step, he later allegedly described as the greatest folly of his life. Today, however, we know that the universe has been expanding continuously since its creation 13.8 billion years ago. Nevertheless, Einstein was remarkably ahead of his time in other respects. As early as 1936, he speculated in an article for the journal Science that a collection of high masses could deflect the light of objects behind them like a lens, thereby creating several images of one and the same structure. This so-called Einstein ring requires a very special alignment. The background source, the lens, and the observer must be exactly in line. Only then will the astronomical motif be distorted into a characteristically round shape. However, Einstein was not optimistic that his theoretical prediction would ever be confirmed by actual observations. He wrote, "Of course, there is no hope of observing this phenomenon directly." Yet, his pessimism was ultimately not borne out by reality. In 1988, radio astronomers using the Very Large Array detected exactly the structure that Einstein had predicted over 50 years earlier. An Einstein ring is a ring of electromagnetic radiation created by the gravitational lensing effect. This effect is caused by the gravity of massive objects, such as galaxies, which bend and amplify the light of objects behind them. Although gravitational lensing doesn't always produce dramatically distorted multiple images, it has turned out to be an outstanding tool for astronomical research. This cosmic lens can make galaxies, stars, and quasars visible that would otherwise remain completely hidden. The sensational first discovery in 1988 was not an isolated case. Experts are now frequently identifying Einstein rings, Einstein horseshoes, which are not fully closed, and completely different spectacular motifs such as the Einstein cross. The Einstein cross is a quasar located 8 billion light-years away. From our vantage point on Earth, it lies exactly behind the center of a galaxy 400 million light-years away. That foreground galaxy acts as a gravitational lens, and due to this lensing, four similarly bright objects appear in an approximate cross shape, with the galaxy core at the center. Gravitational lensing not only produces visually stunning cosmic crosses, but sometimes it also brings to light surprising new discoveries. This was demonstrated again in March 2023, when researchers identified one of the largest black holes in the entire universe using this very method. Although black holes are often regarded as cosmic destruction machines, swallowing everything without fail, it is now considered certain that practically every galaxy harbors a supermassive black hole at its center. In fact, inactive black holes can behave like ordinary massive bodies outside their event horizons. Celestial objects can orbit them stably without any danger of being consumed. Experts now believe that these massive entities play a fundamental role in the development of galaxies. Our own Milky Way is no exception. Its central black hole, known as Sagittarius A*, weighs about 4 million solar masses. That may sound like a lot, but compared to some of its cosmic counterparts, it's relatively modest. There are many black holes out there that weigh billions of times more than the Sun. And 2 years ago, astronomers found one of them. Before this discovery, astronomers had noticed an unusual feature of the central galaxy in the AEL 121 cluster, located about 2.7 billion light-years away. When this galaxy passed in front of a background object, its gravitational lensing effect appeared far stronger than expected based on its visible size, number of stars, and dark matter content. Studies showed that the galaxy AEL 121 BCG deflected the light of background objects across a stretch of nearly 2,000 light-years, forming a distorted arc. A smaller arc was later identified on the opposite side, and its position and shape hinted at the existence of a massive object at the center of the galaxy. The idea that this could be an inactive black hole was obvious from the start. To test this suspicion, astronomers led by James Nightingale of Durham University evaluated new images from the Hubble Space Telescope, focusing on AEL 121 BCG and its gravitational lensing effect. The researchers then ran astronomical simulations on supercomputers to determine what kind of supermassive black hole could cause the observed deviations. The result was astonishing. The simulation showed that a mass monster with 33 billion solar masses must be hiding at the heart of the galaxy. To put that into perspective, this object is near the upper theoretical mass limit predicted for black holes. It also became the first black hole to be added to the cosmic map using gravitational lensing and advanced modeling techniques. The reason this colossus remained hidden for so long is that it is inactive. Unlike active black holes that devour matter and emit energy in the form of light, X-rays, and radiation, inactive black holes are completely invisible unless indirectly detected. This discovery led scientists to a more fundamental question: why do even heavier black holes exist than this one, despite our understanding suggesting they shouldn't? Black holes like TON 618 and Phoenix A challenge our current models. To understand the mystery, we must first consider how massive black holes can get. According to British astronomer Andrew King, the upper limit for black hole mass is around 50 billion solar masses. King used astrophysical models to argue that beyond a certain size, the glowing disk of gas surrounding a black hole, the accretion disk, becomes unstable and collapses. However, this upper limit only applies to black holes growing through their own accretion. If two such massive black holes merge, the resulting object could theoretically reach up to 270 billion solar masses. In this case, the final object would not have a luminous accretion disk, making it harder to detect. This makes the case of TON 618 all the more baffling. Not only does this quasar, located in the constellation Canes Venatici, weigh an estimated 66 to 70 billion solar masses, but it also has a visible accretion disk. Moreover, it shines an incredible 140 trillion times brighter than the Sun. Despite its mind-bending mass, TON 618 is not the final word in cosmic enormity. The black hole known as Phoenix A, located in the Phoenix cluster 8.5 billion light-years away, may be even more massive. According to the latest calculations, it weighs in at an astonishing 100 billion solar masses. This makes it 30 to 34 billion solar masses heavier than TON 618 and a whopping 24,100 times more massive than Sagittarius A*, the black hole at the center of our Milky Way. To put this into perspective, it would take almost 72 days to orbit Phoenix A at the speed of light. And when black holes like Phoenix A and TON 618 start to strain the limits of our understanding, scientists begin to refer to them as stupendously large black holes, or SLABs. These are objects that range between 100 billion and 1 trillion solar masses. For now, SLABs remain theoretical, but many scientists believe they could exist. These black holes would have formed shortly after the Big Bang and consumed massive amounts of matter over billions of years, potentially reaching weights of up to 100 trillion solar masses. And if you found today's journey through the cosmos as fascinating as we did, we invite you to join us here on Space Lab, where science meets wonder and the universe tells its story one mystery at a time. Subscribe to Space Lab to never miss another astonishing cosmic discovery. Until next time, keep looking up. Thanks for watching Space Lab, where science meets wonder. Don't forget to like, subscribe, and keep your eyes on the stars.